Assalamualaikum warahmatullahi and hello. This is the slide presentation for ocean ion fertilization presented by me, Muhammad Kamal Fizi, Jamal Wazi. Okay. This presentation is based on the main journal article, which is Review and Synthesis Ocean Ion Fertilization Experiment, Past, Present, and Future, looking to a future carbon ion fertilization experiment in the Southern Ocean projects. Essentially, what the main article does is make an overview on over the 25 plus years of ocean ionization experiment that were conducted on most on the Antarctic or a specific region where there is a low chlorophyll count but a high nutrient count. And they're looking for this in order to see if they can actually conduct this kind of experiment on the on Korean Southern Ocean. Now, what is a ion hypothesis? Essentially, ion hypothesis is seeding the ocean surface with iron that would make microscopic marine organism like diatom multiplies dramatically, which is called blooming, that might turn cool, that might cool off the planet, or in a layman term, fertilizing the sea with iron by the man himself, John Martin, an oceanographer that create this iron hypothesis. Now, what is ion fertilization? Ion fertilization, based on the main article, is essentially is a drawdown of atmospheric, is to decrease the carbon oxide content. You're using additional nutrient, i.e. iron, nitrogen, phosphorus compound, in order to stimulate the phytoplankton growth and subsequently carbon export, take all the carbon content and export it into a deep ocean, either via the sediment or ocean biological pump. Now, why do we do this? Because there's a studies or there's a report where in Antarctic, the researcher found out the content of an ancient air that is the ancient air or air bubble trapped in an ice core within the Antarctic shows that in the ancient time, which is the last glacier maximum, or which is over 2000 years ago, the carbon content of the atmosphere is comparatively lower, way much lower before the industrial times. And these are the diagram that shows the ion fertilization and John Martin's finding and the hypothesis. This shows that it shows how the normal photosynthesis and the upwelling occur with happen with one another. But you can see the process of it. CO2 get absorbed by phytoplankton alongside with the light, and then it will and then it's either we release oxygen or becoming an release oxygen or organic matter, or be eaten by other organism, or it will go down underneath, or it will settling down. And then when the process of upwelling occur, most of the phytoplankton at the bottom with all the nutrients and with the nutrients and dissolved organic carbon will go up due to the upwelling, and then go up to the upwelling, and that's where all the nutrient will be at the surface level. However, what happened if we introduce iron? Because due to his finding, the John Martin found that iron dust actually spread throughout the world, especially on the surface of the ocean. When iron dust get absorbed by the ocean water, we show that the transfer, the cycles, where the iron get absorbed into water, phytoplankton absorb it, it will go down, with settling down as an organic organic matter, and then when the upwelling process occur, it will go back up. So, but this time the phytoplankton contain an additional nutrient, which is the iron, and now it will increase the blooming process due to the light and the photosynthesis process. This will increase the amount of carbon sink, or the amount of carbon get absorbed by it. And what's the main objective for ocean ionization? Essentially is to be an effective method on stimulating ocean carbon sequestration through biological pump in iron limited, high nutrient on low chlorophyll region. Essentially, try to use this technique on a specific region, which is called HALC, and to see can we make a bloom or on the specific region. And this is where the experiment conducted, where the area of iron fertilization are, where you can see on the aquatic Pacific, Equator Pacific, Southern Ocean, Australia, Atlantic. Now, based on the main diagram right now is the number of where all the experimental locations are. If you go back to this, you saw the number from 1 to 13 where the artificial of experimental ocean ion fertilization. And this is where all the locations are. This is where are all the location where the region that contain low chlorophyll count but higher nutrient count. Now, for the OIF experiment, in total, there are 19 ocean ion fertilization experiments. Now, is there any limitation of this experiment? Yes, there is. The subdivision of fertilized patch, the single ion addition. Usually, most of the experiment, especially on the early one, they only use like one type of iron, and they cannot. The problem with one type of iron, they do not know does that particular iron actually make difference with the rest. So as previous as more experiment continue on for over 25 years, we're getting more different types of iron sulfide. Now, and insufficient experimental period to observe full phase of background. This is due to because the maximum experimentation that were conducted from over 25 years was 40 days, and even by then it still is not enough to actually do the proper observation of it. Sometimes some experiment, especially in a small area, they only observe for 2 weeks, which is not enough. Is it success or not? Well, it depends. Of all the 13 artificial experiments, only 6 significant results, meaning it's all not even half of the experiment actually show a significant difference on it, because due to the limitation and the result of the outcome of it. Only these are the listed one that shows significant difference, where the bloom of the diatom actually shows on that particular region where there is low count of chlorophyll. For the future of the experiment, based on the 25 years of experiment, it shows that in order to conduct any further experiment, the future team must take notes on these 6 factors based on the article, which is the location. The location has to be meaningful to actually show the result, which is why we go for that particular place, which is HNLC. And second word is the timing. Most of the experiment, especially the one that got the storm, that's where it get the storm, and then the bloom of the photosynthesis does not occur because it was not at the right time for the upwelling process to occur. The most important thing for the future thing is to monitor the possible side effect, because this type of experiment, especially there's a statement within the journal itself none none of the well-known establishment researcher don't want to undertake this type of experiment because of the public disagreement or public backlash from the general audience. So this is probably the most important thing, and that's all.